Hello student, welcome to my channel Learn Physics. Today I will be discussing the solution of NEET 2022 question paper. This solution will be extremely helpful to build up your confidence in physics. Okay, now let's start. Now look at this, the compulsory section A, physics. Question number 1. Two resistors of resistance 100 ohm and 200 ohm are connected in parallel in an electrical circuit. The ratio of the thermal energy developed in 100 ohm to that in 200 ohm in a given time. You know the power P equal to, this is the V square by R. In parallel combination, V is constant. Therefore, P1 is to P2. This equal to 1 by R1 is to 1 by R2. So look at this. This is the R2 is to R1. Now R2 equal to 200 ohm and R1 is equal to 100 ohm. So look at this. This is the 2 is to 1. Now option C is correct. Okay. Question number 2. The two hollow conducting spheres of radius R1 and R2, where R1 greater than R2, have equal charges. The potential would be. Now look at this. For charge Q, the potential V equal to Q divided by 4 pi epsilon naught R. Now for a given charge, V inversely proportional to R. So, greater the radius of the conductor, smaller the potential. So, from here, look at this. So, V1 less than V2. Okay. So, potential more on the smaller sphere. Okay. Option 3 correct. Next. Now, question number 3. When two monochromatic light of frequency nu and nu by 2 are incident on a photoelectric metal, their stopping potential becomes V1 by 2 and V1 respectively. So look at this. This is the half E V1 equal to H nu minus W. Now for the second case, look at this. This is the E into V1. This equal to, this is the H nu by 2 minus also W. So look at this. Greater the energy of the proton, greater will be the stopping potential. Look at this. Here energy less but stopping potential more. So the numerical is wrong. Okay. Now question number 4. As the temperature increases, the electrical resistance decrease for conductor but increase in semiconductor. Wrong statement. Increases both, also wrong. Decreases for both, wrong. Increases in conductor and decreases in semiconductor. Okay. Option 4 correct. Next. Now question number 5. If the initial tension on a stress string is doubled, then the ratio of the initial to final speed of a transverse wave along the string is. Suppose initial tension T. So final tension is double. So final tension is double the initial tension. So this is the 2T. Therefore, velocity of transverse wave V is to root over T by mu. This is the V1. And for the final velocity V2, this is the root T by mu. Okay. So look at this, V1 is to V2. So this is the 1 is to root 2. Option 4 correct. Okay. Next. Now question number 6. Look at this. This is the list 1 and list 2. This is the EM wave and this is the wavelength. If we arrange the EM spectrum with increasing order of wavelength, the first becomes, this is the gamma ray, then X-ray, then UV, then visible light, then infrared, then microwave, then radio wave. So look at this. Radio wave has the highest wavelength. Now A is the radio wave. Now radio wave is the highest wavelength. So this is the A. Okay. Now microwave. The wavelength of microwave less than the radio wave. So look at this. This is the microwave. So this is the B. Now infrared is the smaller wavelength than the microwave. So look at this is the C. And finally X-ray, this is the D. Okay, so look at this A2 B3. Look at this A2 B3 C4 D1. So option 1 is correct. Okay, next. Now question number 7. The ratio of the radius of gyration of a thin uniform disk about an axis passing through its center and normal to its plane to radius of gyration of a disk about its diameters. So look at this. This is the numerical of rotational motion. Now we have to, first of all, we have to calculate moment of inertia of a disk about its axis passing through center normal to the plane. So this is the half mr square. Look at this. If this is the half m square, so look at this. If k1 be the radius of gyration, so look at this. K1 is the, this is the r by root. Again, the moment of inertia about the diameter of a disk. Look at this. This is the 1 by 4 m r square. So look at this mk2 square. This is the 1 by 4 m r square. Therefore, k2 equal to r by 2. So look at this. This is the r by root 2 is to r by 2. So this is the root 2 is to 1. Option C is correct. Okay. Now question number 8. A biconvex lens has radii of curvature 20 cm each. If the refractive index of the material of the lens is 1.5, the power of the lens. Look at this, the power of the lens P equal to, this is the mu minus 1 and this is the 1 by r plus 1 by r. Okay, look at this. This is the mu means this is the 1.5 minus 1 and look at this is the 1 by r. So this is the 0.2. Now this is the 1 by 0.2. So look at this is the 0.5 into, look at this is the LCM is the zero point 0.2 and this is the 1 plus 1. So look at this is the 5 into 2 by 2. So this is the 5 diopter is the power of the lens. Okay. Now question number 9. The graph in which show the variation of the de Broglie wavelength of the particle and its associated momentum. You know the de Broglie of lambda equals to h by p. So the graph between lambda and p is the rectangular hyperbola. So look at this. This is option 1 correct. Okay. Now question number 10. When light propagates through a material medium of relative permeability epsilon naught r and relative permeability mu r, the velocity of light v is given by. Look at this. First of all, we have to calculate value of this expression. Here C equal to, this is the 1 by mu naught epsilon naught root under and this is the mu r epsilon naught r. So look at this. This is the root under mu r into epsilon naught r. Look at this. This equal to, this is the 1 by mu and epsilon naught. So this is the V. Okay. So now question number 11. In the given nuclear reaction, the element X is. So look at this. This is the plus 1. So atomic number of X becomes 10. Now 10 is the atomic weight of neon. So neon 10, 22 is the answer for X. Okay. Now look at the options. Look at this. The option C is correct. Okay. 12. An ideal gas undergoes the 4 different processes from the same initial state as shown in the figure. Those processes are adiabatic, isothermal, isochoric, and isobaric process. The curve which represents the adiabatic process, look at this. This is the isochoric process. This is the adiabatic process. So graph 2 represents the adiabatic process. Okay. Now question number 13. The ratio of the distance travel of a free falling body in first, second, third and fourth second. Look at this, the distance travel in 10th second. This is the 0 plus, this is the half g. into 2t minus 1. So for first, so look at this, S1 is to S2 is to S3 is to S4. This equal to, look at this is the 2 into 1 minus 1 is to, this is the 2 into 2 minus 1 is to 2 into 3 minus 1 is to 2 into 4 minus 1. Okay. So look at this is the 1 is to 3 is to 5 is to 7. Okay. Look at this. Option 4 is correct. Now look at this question number 4. The two objects of mass 10 kg and 20 kg respectively are connected by the two ends of a rigid rod of length 10 meter with negligible mass. The distance of the center of mass of the system from the 10 kg mass. Look at this. This is the problem of center of mass. This is the 10 kg and this is the 20 kg. The coordinate of this mass is 0, 0 and coordinate of this mass, this is the 10, 0. So look at this xcm. This is the m1x1. This is 10 into 0 plus 20 into 10 divided by m1 plus m2, 10 plus 20. So look at this. These are 200 by 30. Okay, cancel out. So this is the 20 by 3. So option 3 is correct. Okay. Now question number 15. Energy that will ideally radiated by 100 kilowatt transmitter in 1 hour. Look at this 100 kilowatt. This is 100 into 10 to the power 3 watt. Now 1 hour is equal to 3600 second. So this is the 3600 second. Now watt into second unit is the joule. Okay. So look at this. This is the 36 into 10 to the power 7 joule is the answer. Okay. This is the option 2. Now question number 16. An electric lift with a maximum load of 2000 kg is moving up with a constant speed of 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. The minimum power delivered by the motor to the lift in watt is. Look at this. Here force, look at this, for uniform motion, the force is equal to, this is the mg, this is the mg plus force of friction. Now mg is equal to, this is the 20,000 plus 3,000. This is the force. So this is the 2300. Now power is equal, look at this. Now power equal to, this is the force into velocity. So 23000 into 1.5. This is the watt. Now look at this. This answer is correct. Okay. Now question number 17. A copper wire of length 10 meter and radius this has an electrical resistance of 10 ohm. The current density in the wire for the electric field strength 10 joule. Now look at this. The current density J equal to, this is the I by A. I equal to, this is the V by R into A. Now V equal to E into length of the conductor divided by R into A. Now look at this. J equal to, what is E? Look at this. E is equal to 10. L is the, this also 10 meter. R resistance are 10 and A equal to pi into pi into 10 to the power minus 2 by root over pi whole square. So look at this. These are 10 by, this is the 10 to the power minus 4. Therefore 10 to the power 5 ampere per meter square is the current density. What is the option? Option is 1 correct. Now question number 18. If a soft bubble expands, the pressure inside the bubble. Look at this. If the soft bubble expands, its radius becomes more. If radius more, therefore P excess pressure P proportionate 1 by R. So P decreases. Look at this. Option 2 is correct. Okay. Look at this. Question number 19. Biot-Savart's law gives us the expression for the magnetic field strength of an infinitesimal current element ideal of a current carrying conductor only. Okay. Biot-Savart's law is analogous to Coulomb's inverse square law of charge q, with the former being related to the field produced by the scalar source, ideal later being the produced by the vector source q. In light of above two statements, Choose the appropriate answer of the option given below. Look at this. Inverse square law means the force of attraction repulsion acts along the line joining the two charges. Here, direction of magnetic field is perpendicular to the plane containing ideal vector. So this is not the inverse square law. Okay, so statement 2 is false. Therefore, statement 1 correct and statement 2 false. Okay. Now look at this question number 20. A cell of mass m is at rest initially. It explodes into three fragments having mass in the ratio 2 is to 2 is to 1. If the fragments having equal mass fly up along mutually perpendicular directions with a velocity v, the speed of the third fragment is. Look at this. Here mass m is divided in the ratio 2 is to 2 is to 1. Therefore, look at this, m1 is equal to 2 by 5 m. m2, this also is the 2 by 5 m. Okay, 2 by 5 m. And m3, this is the m by 5. Okay. Now, velocity of two equal fragments, one is directed along x-axis, so its momentum 2 by 5 mv in along x-axis. The other fragments, this is the 2 by 5 mv momentum is directed along y-axis. Suppose third fragment directed along this direction, this is the m by 5 v dash. Suppose this is the p1 vector, this is the p2 and this is the p3. So look at this, from conservation of linear momentum, p1 vector plus p2 vector plus p3 vector, this equal to 0. Okay, so look at this, this is the p3 minus p3 vector, this equal to p1 vector plus p2 vector. Now look at this, p1 and p2 are equal in magnitude and angle between p1 and p2 is 90 degree. So look at this, p1 vector plus p2 vector. So look at this, this is the p3 equal to root under of, this is the p1 square plus p2 square. So look at this, this is the 2 by 5 m v into root. Okay, now this is the m v m by 5 v3. Look at this, m cancel out. Okay, 5 cancel out. So look at this, v3 equals to 2 root 2 v. Okay, option 4 is correct. Now question number 21. A spherical ball is dropped in a long column of a highly viscous liquid. The curve in the graph shown, which represents the speed of the ball as the function of time. Look at this. First of all, velocity of the ball increases with acceleration. Now acceleration decreases to 0 and gains a constant velocity. So this graph represents the velocity time graph of a body falling in a liquid column of viscous liquid. Okay. So look at this, option 3 is correct, that is the B. Okay. Now question number 22. The angular speed of a flywheel moving with a uniform angular acceleration changes from 11200 revolution per minute to 3120 revolution per minute in 16 seconds. The angular acceleration in radian per second square is. Now look at this, omega 1 is the 2 pi by 60 into 1200. So this is the 20. So look at this, this is the 40 pi. Okay. Now omega 2, this is the 2 pi by 60 into, this is the 3120. Now this and this cancel out. Look at this 6. So look at this, this is the 5 and this is the 2. Okay. So look at this, this is the 104 pi. Now angular acceleration A equal to, look at this, this is the omega 2 minus omega 1 divided by time 16. So look at this, this is the 104 pi minus 40 pi divided by 16. Okay, so look at this. This is the 64 pi by 16. So this is the 4 pi radian per second square is the acceleration of the particle. So option C is correct. Now question number 23. The peak voltage of the AC source is equal to. The peak voltage of the AC source is root 2 times the RMS value. Okay. Now question number 24. The dimensions of MLT minus to A minus 2 belongs to the, this is the magnetic permeability. Okay. Look at this. The displacement time graph of two moving particle makes an angle 30 degree and 45 degree with the axes shown in the figure. The ratio of the respective velocity will be. You know velocity v equal to the slope of displacement time graph, that is tan theta. Now look at this. V1 is to V2. This is the tan 30 degree is to, this is the tan 45 degree. Now look at this. Tan 30 degree, this is 1 by root 3. Tan 45 1. So look at this. This is the 1 is to root 3. Okay. Next. Now look at this question number 26. Look at this. This is the forward bias. This also forward bias. So current passes through this. Look at this. This is the forward bias. This is the reverse bias. So no current passes through this. Look at this. This is the forward bias. This is the forward bias. So current flow through this. Now, in the above circuit ABC, potential drop across the two PN junction are equal. Obviously, A and C, because here current flow, so voltage drop across it is equal to voltage drop across it. Here voltage drop across it equal to voltage drop across it. So A and C are correct. Now look at this. Option 1 is correct. Okay. Now question number 27. The angle between the electric lines of force and the equipotential surface. Look at this. The angle between the equipotential surface and electric field lines is always perpendicular to each other. Okay, this is 90 degree. So option 4 correct. Okay. Now question 28. The plane angle and the solid angle have, number 1, both unit and dimensions. Unit but no dimensions. Okay. They have only unit. Angle has unit radian and solid angle has unit steradian but no dimension. So option 2 correct. Okay. Now question number 29. In a young double slit experiment, a student observes 8 fringes in a certain space on a screen when a monochromatic light of wavelength 600 nanometer is used. If the wavelength of light changes to 400 nanometer, then number of fringes would observe in the same region. Suppose width of the region be x. So x is the 8 into beta. Now x equals to, this is the n into beta dash. As lambda decreases, so beta dash also decreases. Now beta dash equals to, look at this, this is the n dash into beta dash equals to beta divided by 600 nanometer and this is the 400 nanometer. So this is the n dash equals to 2 beta by 3. Okay. Now this is the 8 beta. So this is the 8 beta. Now look at this, beta cancel out. So n dash equals to 8 into 3 divided by 2. So this is the 12. Okay. Option 1 is correct. Now question number 30. A light ray falls on a glass surface of refracting index root 3 at an angle 60 degree. The angle between refracted and reflected rays would be. Suppose this is the line of reflection. This is the normal. Now a ray incident along this direction. Okay. So look at this. This angle is equal to 60 degree. Now we have to calculate the angle of refraction. Look at this. This is the angle of refraction. Now we have to calculate angle between the reflected ray, that is this ray and this ray. Suppose this angle will be theta. Okay. Now look at this. This is also 60 degree. Angle of incidence equal to angle of reflection 60 degree. So look at this. This 60, this theta and these are is equal to 180 degree. So 60 degree plus r plus theta equal to 180 degree. Now theta equal to, this is the 180 degree minus 60 degree minus r. So this is the 120 degree minus r is the theta. Now we have to calculate r. Look at this, root 3 equal to, this is the sine 60 degree divided by, this is the sine r. Okay. Now this is the root 3 and sine 60, this is the root 3 by 2 divided by sine r. Okay. So sine r is equal to half. That is, this is the sine 30 degree. Okay. So r equal to 30 degree. If r 30 degree, then theta equal to 90 degree. Okay. So look at this, option 4 is correct. Now question number 31. In half wave rectification, if the input frequency is 60 Hz, then the output frequency would be also 60 Hz. Okay. Now question number 32. A body of mass 60 gram experiences gravitational force 3 Newton when placed in a particular point. The magnitude of gravitational field intensity, the field intensity equals to force by mass. Okay, what is force? Force is the 3 Newton, mass is the 60 by 1000 kg. Okay, this cancel out. So look at this, 300 divided by 60. So this is the 50 Newton per kg. Okay. Now look at this question number 33. A square loop of side 1 meter, resistance 1 ohm is placed in a magnetic field of 0.5 Tesla. If the plane of the loop is perpendicular to the direction of magnetic field, the magnetic flux through the loop is. Okay. The magnetic flux phi equal to, this is the B ANA. Okay. Now look at this here. A equal to 1 meter into 1 meter. So look at this. N equal to 1. Look at this. And B is the 0.5. So look at this. This is the 0.5 Weber. Okay. Now option C is correct. Okay. Now question number 34. Let T1 and T2 be the energy of an electron in the first and second excited state of hydrogen atom. Now for first excited state, N2 equal to, this is the 2. For second excited state, N equal to 3. Okay. So look at this, the energy T1 is to T2. Energy T directly proportional to Z square by N square. So here T directly proportional to 1 by N square. Therefore, look at this. Therefore, T1 is to T2. This is the 1 by 2 square is to 1 by 3 square. So look at this. This is the 9 is to 4. Option 1 is correct. Okay. Now question number 35. A long solenoid of radius 1 millimeter has 100 turns per millimeter. So you have to calculate the number of turn per meter. So this is the 100 turn divided by 1 by 100, 1 by 1000 meter. So look at this. This is the 10 to the power 5 turn per meter. Okay, no problem. Current I. So I is equal to 1 ampere. Okay. Now we have to calculate the magnetic field strength at the center of the solenoid. The magnetic field strength mu naught equals to N into I. Mu naught is the 4 pi into 10 to the power minus 7 into 10 to the power 5 into 1. So look at this. This is the 4 pi into 10 to the power minus 2. Look at this, option C is correct. Okay. Now question number 36. Two pendulum of length 121 centimeter and 100 centimeter start vibrating in phase. At some instant, the two are at their mean position in the same phase. The minimum number of vibration of the shorter pendulum after which the two are in phase at the mean position. Now look at this. We have to calculate the ratio of time period. Look at this. The ratio of time period T1 is to T2 is equal to root over 121 is to root over 100. Okay, because time period directly proportional to root over L and inversely proportional to 1 by root over G. Okay, so look at this. This is the 11 is to 10. So time period of this is 11 and time period of this is 10. Now what is the LCM? What is the LCM of 11 and 10? Look at this, the LCM of 11 10 is 110. So number of oscillation completes, this is the 11 by number of oscillation completes by longer pendulum 110 by 11. So this is the 10 and this is the 11. So the shorter pendulum completes 11 oscillation when they come in the same phase. Okay. Now question number 37. The volume occupied by the molecules contained in 4.5 kg water at STP if the intermolecular forces vanish away. Now, first of all, we have to calculate the number of mole present in 4.5 kg water. So look at this. This is the 4.5 is equal to 4500 gram. So number of mole, this is the 4500 divided by 18 mole. Okay, you know the volume of 1 mole of a gas is equal to 22.4 liter. If liter is converted into meter cube, you can get this. Okay, now look at this. This is the 4.5 by this is the 18 into this is the 22.4 into 10 to the power 3 into 10 to the power 3. Okay, now this 10 to the power 3 comes from this. Okay, therefore this and this cancel out. Therefore look at this, this is the 4.5 and this ratio slightly greater than 1. So this is the obviously 5.6 meter cube. Okay, now question number 38. Two transparent media NB are separated by the plane boundary. The speed of light in this media are 1.5 in 10 to the power 8 meter per second and this is the 2 into 10 to the power 4 meter per second respectively. The critical angle for the ray of light in these two media. Now you know mu1 V1 is equal to mu2 V2. Okay. So look at this, mu1 into 1.5 equal to into 10 to the power 8 equal to mu2 into 2 into 10 to the power, this is the 8. Therefore, you get mu1 by mu2, this is the 2 by 1.5, that is 4 by 3. Okay. So look at this, first medium is the denser medium and second medium is the rarer medium. So critical angle theta c, this equal to sine inverse, this is the Ri of the rarer medium by Ri of the denser medium. So this is the sine inverse 3 by 4. Okay. Now look at this. This option is correct. Okay. Now question number 39. Okay. Matching the list 1 and list 2. Here physical quantities are given and this is the dimension given. This is the very easy sum for you. If you just know the physical quantity. Look at this gravitational constant. Gravitational constant is the Fr square divided by m1 m2. So here in dimension of gravitational constant there will be m inverse. So look at this. This is the A. B is the gravitational potential energy, the work done. Look at this. This is the B. Now gravitational potential, work done by mass, so square of velocity, this is the C. And gravitational intensity, this is the force by mass, so this is the acceleration, this is the D. So look at this option 3, look at this A2, B4, C1 and D3. Okay, next. Look at this question number 40. A series LCR circuit with a inductance 10 Henry, capacitance 10 microfarad, resistance 50 ohm is connected in AC source of voltage V equals to 200 sine 100t volt. If the resonant frequency of the LCR circuit is nu naught and the frequency of the AC source is nu, then now look at this here. Now look at this here. Nu is equal to, this is the 100 radian per second. So this becomes nu equal to 50 by pi hertz. Okay. Now resonant frequency nu naught, this equals to 1 by 2 pi root under LC. Look at this, this is the 1 by 2 pi and L is equal to this is the 10 Henry, and C is the 10 microfarad. So look at this, this is the 1 by root under of, this is the 100 into 10 to the power minus 6. So look at this is the 1 by 2 pi, this is the 100. Okay, so this also 50 by pi hertz. Okay, so look at this, option C is correct. Nu naught equal to nu equal to 50 by pi hertz. Okay. Question number 41. A ball is projected with velocity 10 meter per second at an angle of 60 degree with the vertical. So angle with the horizontal, look at this. This is the 30 degree. No problem. This is the 10 meter per second. Its speed at the highest point of its trajectory. The speed at the highest point, this is the 10 cos 30 degree. Now cos 30 equals to root 3 by 2. So this is the root 3 divided by 2. Now this is the 5. So 5 root 3 is the velocity of the particle at highest point. Okay. Now question number 42. For a ampere circular law for a long straight wire of circular cross section carrying a steady current, the variation of the magnetic field in the inside and outside region of the wire. The magnetic field in the straight conductor is linearly increases within it and then decreases with inversely proportional to B is, and in outside region it is inversely proportional to 1 by r. Okay, so this is the B proportionate r and this is the B proportionate 1 by r. Now look at this, option 4, a linearly increasing function of distance r up to the boundary of the wire, then decreasing with 1 by r. Okay, so option 4 is correct. Now assertion reasoning question. The stretching of a spring is determined by the shear modulus of the material of the spring. Yes, in spring, stretching of the spring depends on shearing modulus. Okay. Now, a coil of spring of copper has more tensile strength than the steel. No, no, no. This is the false statement. Therefore, assertion correct, reason false. Okay. Now, question number 44. This is a logic gate. Look at this here, A and B. So here look at this, A and B not. Look at this here, A not, B. So look at this here, A not, B not. So look at this, C becomes, this is the A and B not plus into, look at this is the A and B not. Okay. So look at this is the A, this is the B, this is the A and B, this is the A not, this is the A and B not, this is the A not, A, A, A not, B not. Okay, look at this, 0, 0. This also 0, this is 1. Look at this, A and B 0, so this is the 1. Now A naught into B, this is the 0, so this is also 1. So C is equal to 1. Okay, now 0, 1. Look at this, A, so this is the 0, this is the 1. Now A and B 1, so this is the 1 means this is the 0. Okay, and a naught is the 1 into B is the 1 into 1, so this is the 0, so this is 0. Okay, now again this is the 1, this is the 0. Now look at this, A and B, this is the 0, and now look at this, A naught, this is the 0. Now A and B naught, this is the 1. Now 0 into this is the 0, so 0, 0 is 1, so this is the 1. Again 1, 1. Look at this is the 1, this is the 0. Now if this is the 1, so A not B, this is the 0. Now look at this, A not 0 into B, so this is the 1, so this is the 0. Okay, at this, option 4 is correct, 1, 0, 1, 0. Okay, next. Now question number 45. A nucleus of mass number 189 splits into two nuclei having masses 125 and 64, ratio of the radius. You know the ratio of the radius of the nuclei is R proportionate A to the power 1/3. This is the mass number. Now here ratio of radius R1 is to R2. So look at this. This is the 125 to the power 1/3 is to 64 to the power 1/3. So look at this. This is the 5 is to 4. Okay. So option 4 is correct. A, a Wheatstone BG used to determine the value of unknown resistance X by adjusting the variable resistance Y. Look at this. This is the unknown resistance and this is the variable resistance. Okay. For the most precise measurement of X, the resistance P and Q. Look at this. The in Wheatstone principle, the unknown resistance X be determined if the value of P, Q, X and Y are in the same order. So look at this here, option 3, the should be approximately small. P, now look at this option 3, P and Q almost equal and small. Okay. Now look at this question number 47. The area of the rectangular field in meter square of length, this is the 55.3 meter and breadth 25 meter. Rounding of the values of the correct significant digit. Now area equals to length into breadth. In multiplication, here number of significant figure is 3. Here number of significant figure is 2. The significant figure of the result, that is significant figure of the area, should be 2. So look at this. This is the 2. So option 1 correct. Okay. Now question number 48. A big circular coil of 1000 turn and average radius 10 meter is rotating about a horizontal diameter at 2 radian per second. If the vertical component of Earth magnetic field at that place is 2 into 10 to the power minus 5, 2 into 10 to the power minus 5 Tesla, and the electrical resistance of the coil is 12.5 ohm, then maximum induced current in the coil. Now you know the maximum induced EMF E equal to, this is the N B omega A. So maximum current I is to N B omega A by R. Now what is the number of turn? Look at this, number of turn is the 1000. B is equal to, look at this, 2 into 10 to the power minus 5 Tesla. Omega is the 2 radian per second, and area of the coil, look at this. This is the radius is the 10 meter. So this is the pi into 10 square. So this is the pi into 100. Now look at this here. This into this is the 10 to the power 5. 10 to the power 5 into 10 to the power minus 5. So look at this. This is cancel out. Now look at this. This divided by this is the resistance R equals to 12.56. So you get 2 into pi divided by, look at this. This is the 12.56. Now 4 pi equal to 12.56. So this is the 1 ampere. Okay. This is the correct. Next. Now question number 49. 2 point charges minus q and plus q are placed at a distance L as shown in figure. This is the minus q and this is the plus q. L is the length. The magnitude of electric field intensity at a distance R greater than L is. You know, now the electric field due to dipole on its axis is inversely proportional to 1 by RQ. Okay. So look at this, option 3 is correct. Okay. Look at this last question, question 50. A capacitor of capacitance C equal to 300 picofarad is charged fully by 100-volt battery B as shown in figure. Then it is disconnected from the battery and connected to the another uncharged capacitor of capacitance C equal to 300 picofarad shown in figure. The electrostatic energy stored in the system. Look at this. This is the 100-volt. So charge in it, this is the C into 100. C equal to, this is the 900 picofarad. So charge is equal to, look at this, this is the 900 into 100 into 10 to the power minus 12. Okay, no problem. So look at this, this is the 9 into 10 to the power minus 8. Okay, Now when this charge capacitor is connected to another charge capacitor, so the charge is equally divided between them. Okay, so look at this, charge on each is the 9 by 2 into 10 to the power minus 8. So energy, now energy equal to, look at this is the energy, W equal to, this is the 2 into, this is the Q square by 2C. Okay, this is the 9 by 2 into 10 to the power minus 8 whole square divided by C, this is the 9, okay, into 10 to the power minus, this is the 12. So you get 2.25 into 10 to the power minus 6. Okay, many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. Okay.